Hello there, I'm Thomas. That is the German American pilot flying Boeing 787-900 flight with India flying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport runway 1449 localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900. I'm gonna start and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel. Uh, the, uh, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the rate of climb and descent of the aircraft within hundreds and thousands of feet per minute, and the target altitude selected from the autopilot and flight director system panel. We have also the altitude indicator with the pitch slider degrees and the bank angle in degrees. We have the ILS localizer. We have the vertical glide slot and the horizontal localizer. The instrument landing system that guides the aircraft into the airport runway for landing, and aligns it with the magnetic North Pole heading of the runway. So we're gonna have that also for display. The ILS localizer crossbars. And also we have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbar for automatic guidance of the aircraft. We have the flight mode on 0 with the autopilot, and the auto throttle, laser, and vertical navigation modes. We have also the navigation display. You can see the navigation display. We have the horizontal and vertical profile of the aircraft as it flies, and the horizontal and vertical profile of the terrain around you. We have just created a flight plan using the flight management computer. We input all the data that we have stored in the flight management computer. So we used the departure airport and runway, and the destination airport and runway. We have the airports displayed in the navigation display, so you can see the airports around you where they allocated the runways that we have to use for takeoff and for landing. The voice stations, the EDFs, and the waypoints. We have the waypoints, which are the horizontal vertical navigation fixes the aircraft has to fly through using the flight plan that we have already created here. So you can see, using this flight management computer over here, I have created a flight plan. This is the flight management computer. I input all the data and these displays. I create the flight plan. You can see this purple line from takeoff, climb, then cruise, then descent, approach, and landing into the runway here. You can see it also displayed here in the integrated display. So we're gonna see how this works. We have the magnetic heading and track, magnetic north pole, and magnetic variation depending on where we are in the world. You can see the terrain map, as I told you, with the airports, the waypoints, and the navies. You can see the weather radar and terrain reflections from the weather radar. You see other aircraft flying around us using the transponder. The ASP and ADC transmits a receiver that transmits and receives our own frequency to other aircraft and the air traffic control, and receives from other aircraft and calculates the altitude difference, the airspeed of the other aircraft, and the closing in velocity between our aircraft and the other aircraft, the direction they have, the bearing towards our aircraft, and the distance they are located. So this generates the TICA system, the Traffic Collision Alert Advisory System, using the passive radar, the transporter. So the ADSP and ADC transporter that we have. So I'm gonna show you how to use the navigation display for displaying the flight plan. So I input all the data for this flight, create a flight plan or a flight path or a route for this flight using all the data of the aircraft. We use the takeoff gross weight of the aircraft, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, how much fuel and where is stored in the left and right wing tank, in the center tank, the fuel balance between the left and the right wing and the center. This calculates also the center of gravity of the aircraft, the flight management computer that we have, and the mean aerodynamic chord position of the aircraft, 23% of the Mach, or the mean aerodynamic chord of the forward wings position. It's the position where the maximum aerodynamic lift occurs in the forward wings by using the aerodynamic flow, the flow of the airflow of the air mass around, below and above the wings as the aircraft flies, and this generates the pressure difference between we have higher pressure below the wings and lower pressure above the wings for creating the lift force that pushes the aircraft up into the air using the wings. So we have the thrust from the engines, and I'm gonna show you all these things, the drag, the forces that act on the aircraft. So this calculates the mean aerodynamic forward position of the forward wings, the center of gravity, and the horizontal tail trim stabilizer position from takeoff, climb, cruises, and approach the landing. We're gonna have the horizontal tail of the aircraft being trimmed either manually using the trim switch in the control wheel of the aircraft, or automatically using the auto trim system from the autopilot and the auto throttle. So you will see also that the horizontal trim stabilizer position of the aircraft, and we're gonna have also I'm gonna show you how to use the takeoff gross weight of the aircraft for this calculation, the mean aerodynamic forward position, the horizontal trim stabilizer, and the flaps position for takeoff. We're gonna use 15 degrees of flaps that increase the lift from the wings, and this allows the aircraft to find slower airspeed. Also for takeoff and for landing, so we're gonna have this also calculated, and we're gonna have the runway. We have the Zurich International Airport runway 14. We're gonna use the runway 14 for takeoff and for landing, the Lszh of Zurich International Airport. So we're gonna have this runway. We have the runway length, the runway slope, the wind direction and speed, the barometric pressure of the outside air, the density of the air and the temperature of the air, and also the runway conditions, if it is ice, dry or wet. We're gonna have all the calculations about the takeoff speeds. This is gonna give us, using the flight management computer, the V1, V-rotate, and the V2, which is the takeoff climb speed, and we're gonna have the V2 plus 15. It's gonna be our flight speed after takeoff. So for this initial climb above the runway, we're gonna have also the C's that are arranged with departures that include the horizontal and vertical navigation fixes for the initial climb after takeoff. We're gonna climb to the cruise level, like 25,300 feet for this flight. So we're gonna cruise and then come make a turn. We're gonna cross transverse some waypoints as we're gonna fly. Horizontal and vertical navigation fixes. We're gonna have then the top of climb, top of descent. We're gonna start the descent back into the airport, and we're gonna have the stars, the SADA terminal arrival waypoints and fixes for the final approach of the aircraft into the runway. The long final and the short final approach. We're gonna align the aircraft with the runway using these waypoints, and also we're gonna have the ILS localizer, the instrument landing system, that is gonna help us guide the aircraft into the runway. We're gonna use the vertical rise slope and the horizontal localizer for alignment. We're gonna align the aircraft with the magnetic north pole, magnetic heading north pole for this landing. And we're gonna use the ILS localizer, the instrument landing system. We're gonna have the ILS localizer crossbar, so I'm gonna show you how to use manually for landing. We're gonna have the ILS localizer frequency also displayed in the primary flight display, and it's gonna be selected automatically already from the flight management computer when we created the flight plan. Is stored in the flight management computer, the flight plan, flight path route. So we're gonna guide the aircraft all the way down for landing into the runway 14 in the Zurich International Airport, Lszh. So we're gonna have a complete flight from takeoff, climb, cruises, and approach and landing. In the end part of the video, you're gonna see that. So stay tuned until the end part of the video. You're gonna see the complete flight. I'm gonna show you how to hand fly the aircraft. After showing you all all the functions of the aircraft systems. I'm gonna show you the displays, the autopilot, the thrust levers, the flight controls. I'm gonna show you the displays, the system displays, the electric, the hydraulic, the fuel system, the left and right wing fuel tank, the center tank, the fuel booster pumps, the fuel jettison, the electronic engine control for the engines with the auto start, the flight control computers and the flight control surfaces, the inertial reference system, their data computer system. I'm gonna show you also that. So we're gonna have the IRS localizer, the instrument, the inertial reference system that we have for alignment with the North Pole and the coordinates of the aircraft and the GPS position, and also the air data. I'm gonna show you that. So we're gonna have all these things. I'm gonna make an engine start demonstration. I'll show you also the electrical. I'll show you the APU, the auxiliary power unit. We have a smaller turbine in the tail of the aircraft. It's gonna help us to start the engines in a cold and dark aircraft. It's gonna provide electric power alternate current and also pressurizer to start the compressor. The pressure of it's gonna give the initial pressure into the engine starter. And also we're gonna have the ignition using the alternate. So I'm gonna show you all these things. So stay tuned. Right now I'm gonna show you over here, so you can see the flight plan. You can see the whole cockpit right now. Nice view of that, of the Boeing 787-900. You can see everything is functioning here. So you can see also the outside view. You can see the flight plan, as I told you. You can see the horizontal. This is the flight controls. You can see the horizontal trim stabilizer over here. So we have the trim stabilizer for the horizontal tail. I'm gonna show you the flight controls. You can see the pitch trim here, the alternate. So you can see this. You can use this pitch trim here. These switches to trim up and trim down the aircraft in flight. We have the parking brakes also, as you can see. The flight controls also have, as I told you, horizontal trim stabilizer. This is the cutoff switch for the horizontal trim stabilizer auto trim function. So if we have a failure of the horizontal trim stabilizer, if we have a failure of the L2 or R2 hydraulic systems, over here in the overhead panel you can see the hydraulics. So if you have a failure of the L1 or R2, we're gonna have malfunction of the auto trim system from the autopilot and the auto throttle. So we disconnect these two switches from the normal to cut off, open the guarded switch, and then use only the alternate pitch trim during flight, or we can use only the manual over here, the manual trim pitch trim switch. So we use this trim switch to trim the horizontal tail of the aircraft. You can see the horizontal tail over here, located over here. It balances the aircraft in flight. So we use the pitch trim all the time of the horizontal tail. We use climb and descend the elevator, and also trim it in a position in accordance to help us balance the aircraft in flight. So I'm gonna talk to you about the forces, the Newton's physics, and aerospace engineering, aerospace engineering factors also used for flying the aircraft. So you can see the wings hold, the forward wings hold the weight of the aircraft as the aircraft flies. We have the vectors, the thrust from the engines. We have the lateral axis from wingtip to wingtip, the longitudinal axis from nose to tail. The transverse is also the horizontal tail axis. So we're gonna have the Newton's physics and the Bernoulli theory of fluids, and this creates aerospace engineering. So we have the principles, the tail, the vectors from the tail. We have the mean aerodynamic chord position, about 23% for this aircraft of the forward wings. Here is the maximum aerodynamic lift created. Is also where we calculate the center of pressure behind it, and the center of gravity transverses over here, approximately close to the main aerodynamic core position, forward or aft. We can balance the aircraft in flight. So usually it's behind it. So the main aerodynamic core position, 23% of the mark, is also the position where the stall occurs above the wings. The airflow of the air mass becomes detached as the aircraft flies for a given angle of attack and an airspeed and altitude. So we're gonna have the aircraft stall if we not be careful. So I'm gonna show you also how to avoid the stall. We have the wings. You can see the bottom surface is more flat. So as the aircraft accelerates for takeoff using the thrust from the engines, this creates a lower air pressure below the wings because the airflow of the air mass is moving slower below the wings. So we have higher air pressure below the wings, which pressurizes the aircraft up into the air. And we have the top surface of the wings. You can see they have a curvature, so this creates a lower air pressure above the wings because the air is moving much faster above the wings. So this creates lower air pressure that sucks the aircraft wings up into the air above the wings. So we have the differential pressure below and above the wings. So I'm gonna show you a couple more things over here. I'm gonna show you the flight controls now. So we're gonna have the flight controls. So I'm gonna show you the flight controls now of the aircraft. I will explain the function of the flight controls. So I'm gonna show you the flight controls and I will explain you the function of the flight controls of the Boeing 787, approximately the same for almost all aircraft. So we have the control yoke here that controls the horizontal tail using the control column. For climb and descent, we move the elevator up and down to climb and descend the aircraft. In flight also we have the ailerons and the spoilers. We use the control wheel of the yoke to make bank rolls left and right, and we have the rudder pedals for nose wheel steering. And also for flight we have the rudder function and the rudder pedals for making yaw turns using the vertical tail of the aircraft, turn left and right. We have also the toe brakes in the rudder pedals. So I'm going to show you also the thrust levers function using here the flight controls that I have the side stick, the Logitech Stream 3D for controlling the flight controls of the Boeing 787-900. So I'm going to show you the flight control, then the rest of the scissors I'm going to have to start. Maybe I need to get a better maybe lighting over here. Show you a little bit of these flight controls, show you inside from the cockpit and outside, explain you the functions. So you can see here we have a side stick that is almost identical to the Airbus side stick. As you can see, we can climb and descend the aircraft here. We can make turns to the left and the right, and also use the rudder pedals for making your own turns. So you can see climb and descent. We use the horizontal tail over here. You can see the outside view, the horizontal tail for climb and for descent using the flight controls. Maybe we need a little bit better of lighting. So hope you like the flight controls function. Maybe a little bit better lighting here. Yeah, we have it better lighting. So you can see like this, we can climb the aircraft and we can descend and also make the tail turn like this. So you can see here. So this is the climb or the descent of the aircraft, and the turns, and also the ailerons, the spoilers, and the wings. So you can see the outside view of the flight controls of the Boeing 787. We have full all control. Make turns and climb and descend. So I'm gonna show you also the inside view of the Boeing 787 flight controls right now, how to use the flight controls of the aircraft from the inside. The same principle, you're gonna see the yoke moving, the rudder pedals and the thrust levers, and also the horizontal trim stabilizer. So stay tuned for that also. So I'm gonna show you now the flight controls from the inside. So you can see here again, as I told you, you can see we can climb and we can descend the aircraft. Make turns to the right, make turns to the left. You can see how fast it's moving. You can see both sides, the captain and the first officer are moving simultaneously. They're interconnected. When you move the one, the other one also moves the same way. So you can climb and descend. You have the control column of the yoke, and you can also make turns left and make turns right. You have the ailerons and the spoilers, and also the rudder pedals like these. Also the thrust levers here. You can use the thrust, adjust the power from the engines like this. And also we have the horizontal trim stabilizer. So hope you like the Boeing 787, the flight controls, explanation and function. So I'm gonna show you now the rest of the system. You can see the side stick deflection is proportional to the yoke deflection, as you can see, proportional. And we have the control of the aircraft, both engines. You can control the engines and all the functions, the horizontal trim stabilizer. So now I'm gonna show you the rest of the system. We have about so we have about pretty much 44 minutes for this video length. So I'm gonna show you the rest systems of the aircraft cockpit. The autopilot flight director system panel with thrust levers. So I'm gonna start with the autopilot flight director system panel. You can see we have the autopilot engage and disengage switch, the auto throttle left and auto throttle right engage and disengage switch, the flight director engage and disengage switch. We have the airspeed select knob. You can select an airspeed, nautical miles, knots or Mach speed, and this will command the engines. We have the GNX engines installed in our Boeing 787 aircraft, one in the left wing, one in the right wing. For symmetrical thrust and redundancy, each one contains a gearbox with the FADEX. The FADEX are the full authority. These electronic control computers, one installed per engine. Gearbox controls the engine's functions. So this produces the thrust that moves the aircraft forward. Select the airspeed, nodes, nautical miles, Mach speed. We have the modes for the flight level change, the VNAV and the LNAV, the vertical navigation, the lateral navigation, which take all the data from the flight management computer. So you can see we have the thrust levers to adjust also the engine's thrust. Here you can see the engine's indications here in this display. The autopilot flight director system panel. So I'm gonna set the autopilot flight director system panel. We have the heading, the bank angle, also limit. We have the vertical rate of climb descent of the aircraft at 100,000 feet per minute, and also the altitude select. You can select an altitude in thousands of feet, hundreds of feet, and select the mode for that. So the engine contains the gearbox. The gearbox contains the FATEX. The FATEX are the fuel fluid electronic control computers installed per engine. Gearbox will channel redundancy. One channel fails, the other takes over. Controls functions displays all the engines data and function using the upper and the lower ACAS and indication for our system display, like the N1, which is the low speed starter and the low pressure compressor and turbine of the turbofan, which is engines, the exhaust gas temperature per engine, the fuel flow per engine per hour, 1000 kilograms or 1000 pounds. The N2, which is the high speed starter and the high pressure compressor and turbine of the turbofan engine. We have the oil pressure, oil temperature, oil quantity, and the vibration of the N2 states of the engine. Also, the FATEX controls, monitors, and displays engine start, engine shutdown, engine failures. We have the fuel flow into the engines, the fuel metering units. We have the outflow air, the pressurizer from the engines. We have the bleeder from the bypass stage, and also from the 5th and the 9th stage of the high pressure compressors. So we have this bleeder used for hydraulic fluid pressurization, weakened engine RTIs, air conditioning and ventilation, and also for cabin pressurization system. Mainly, also we have the pressurizer from the APU, the auxiliary power unit. I'm going to search how to use that, which admits pressurizer into the engine when you have the engine start. So the engines also control the pressure inside the engines, over pressure, under pressure, and regulates the outflow valve's position into higher and lower stages to increase or decrease the pressure inside the engine stages. So as we climb also the aircraft from the sea level over 20,000 feet, 30,000 feet, or 40,000 feet above the sea level, as we climb to higher altitudes like 10,000 meters above the sea, 12,000 meters above the sea. So we're gonna have, as we climb higher from the 0 feet level, we're gonna have lower air pressure. The air pressure is becoming half than that of the sea level as we climb higher. The air density also is half, and the temperature is decreasing, is becoming freezing, like minus 30, minus 40, minus 50, minus 60 degrees below Celsius degrees below zero. So this is gonna create also the aircraft flies into higher airspeed rate, like 2 or 3 times faster than that of the sea level. So we have a difference of airflow into the engines from the front fan of the engines, from the turbofan to the engines for compression and fuel mixture. So we have a different fuel mixture request every second, and this is calculated and adjusted using the FATEX, the fuel fluid electronic control computers, each one installed in the engines gearbox. So we have also the pressurizer. As I told you, I'm going to show you over here the pressurizer stages. I'm going to show you some displays. So we turn off onto the manual mode the pressurization. You're going to see these switches. You're going to see the stages displayed here. So we have, as you can see, all the engines data. We have the N1, which is the low speed starter and soft, is in the idle right now, 19.8%. We have the maximum takeoff, 100.8. We have the green, red, and yellow limit. The messages. So this is the low speed starter, soft, low pressure compressor turbine on the left and the right engine. The exhaust gas temperature per left and right engine. The N2, which is the high speed starter, soft, the high pressure compressor turbine of the left and the right engine. All fuel flow per inch per hour, left and right engine, thousands of kilograms for 1,000 pounds, oil pressure, oil temperature, oil quantity, vibration of the N2 stage of the engine. Other information, we can see the landing gear over here is up and down. We have the position, the landing gear extend and retract here, alternate gear, lock override over here for the landing gear, auto brakes over here, rejected takeoff. So you can see also other data. You can see the gross weight of the aircraft, including the fuel on board, total fuel, the temperature of the fuel, the saturated air temperature. So we have also the pressure from the left and the right engine, which is admitted for cabin pressurization. The outflow valves also from the cabin. the flaps position, the horizontal tail trim, and the rudder trim position over here. So you can see also navigation display. You can see I'm gonna show you now. I'm gonna set the autopilot, then we're gonna start the engines. We're gonna have the engine start demonstration. So I'm gonna set the airspeed here. For takeoff, you can see the auto throttle left and right. Over here, flight director on and off. We can have the LNAV. We have the flight director on. So this will give us some messages. The bank angle also. The heading select, we're gonna select a heading. The same like the runway we're gonna use for takeoff. So we are very close to the takeoff, to the flight of the aircraft. The vertical speed also. We can descend the aircraft like this. You can see the slider moving here. And the bank angles, the altitude. So we're gonna set the altitude for cruise level. Have two flight directors over here, and the FS displays. So the flight management computer, we have the flaps position here. Retract and extend the flaps. You see the flaps position over here. So we have the fuel control, left and right engine, the thrust levers, auto throttle disconnect switch. You press this switch, you disconnect the auto throttle. Takeoff, go around switch, thrust reverse like this. So you engage the thrust reverses like this. Over here you can see the reverse with green, and this opens the reverse flow to the engines, as you can see. So you can disengage the reverse. And re-engage it. So this disconnects the reverse thrust. So we have, as I told you, horizontal trim stabilizer, parking brakes, alternate trim, fuel flow control, left and right engine, engine fire, left and right engine, pull out and switch. Also closes the fuel flow of the engines. Transporter here, radio communication panel, rudder trim. So you can see here now we have engaged the airspeed from the autopilot flight director system panel. Target airspeed, target altitude, pitch altitude in flight, vertical rate of climb descent of the aircraft, and the barometric altitude where we are located right now, flight mode annunciator, radio altitude of the ground level. So this is all the air data, and we have a couple more things to do. So you will overhead panel, electrical left and right engine, IDG, the gray drive generator, generator controller, the APU. We're gonna start the engine, so we need to use the APU start like this. So it's already start. The battery, APU generator battery, primary flight control computers in the auto position, heading reference and IRS and infra reference system, flight control surfaces, other systems, window sheet, Rammel turbine. Over here the hydraulics. So we need to know the hydraulics pressure from the left and the right engine, and the electric C1 and C2. We can turn off if we need, like this. You will see. So this turns off like this. So this also turns off the right engine. So you can see we have them both off. We can turn on again, and the other side. So we have full control like this of the hydraulics system. We have the fuel on board, the left and right wing fuel tank. You can see the pressure of the fuel booster pumps, the center also, balance. So this is the fuel suites. We can dump some fuel if we need. If we are the suites, the electronic engine control, the auto start system. Here you can see the engine, the cargo fire and the APU fire control. The wing and engine got the eyes here, very important. We're gonna have it in the on or auto position also. The cabin pressurization system. So this is the outflow air here system from the left to the right engine and from the APU. We're gonna use the pressurization for climb and descent if we have the manual. Open and close the outflow valves and set the cabin altitude. So this is all the overhead panel. In general, we have also the lighting system of the aircraft and the windshield wipers here. The head-up display. So this is all the systems we need right now before doing the engine start demonstration. So I'm gonna use also some lighting, and I'm gonna show you the last part before doing the engine start demonstration. I'm gonna show you a little bit of the systems here, the display. So we have systems display like in the Boeing 787, in the Boeing 777. Identical. So you can see the diagram, the electric system, the hydraulics, the fuel, the engines, all the systems, the cabin pressurization. You're gonna see the same diagrams here. So you can see we have the hydraulics, the quantity of the hydraulics, the APU is running, the oxygen and the liquid cooling, the electric left and right engine, IDG 120 to 200 volts, 400 Hz frequency, alternate current, either left and right engine. Also the battery 31 volts right now, and the load set, the APU battery also in this side, and the APU is running. So this is electric diagram, hydraulics. You can see the left and the right engine hydraulic pumps, electric C1 and C2, C2 electric turbines. So we have where the hydraulic fluid goes, which flight controls use it. You can see the quantity of the hydraulics over here, 0.99%, and the pressure 5000 psi system. So we have engine driven and electric driven, shut-off valves, other systems. So we go into the fuel. You can see the fuel on board. You can see the same diagram again as I told you, hydraulics over here and fuel. So you can see the fuel in the left and the right wing tank, how much fuel you have. If it is balanced, 11.2 thousand pounds each left and right wing, 12,000 pounds in the center tank. You can see the left and the right engine is running. You can see the symbol of the engine, low and high pressure fuel valves into the engines. We have fuel flow, left and right engine. The APU is fed from the left wing using the DC motor. Also you can see the fuel booster pumps forward and aft. The crossfeed valve is closed right now, but if we open it, we can feed either engine with either pump or either tank if we have an engine leak, if we have a wing leak, for instance, or a pump failure. So you can see also here the minimum fuel temperature over here is minus 37 degrees Celsius, below which the fuel will freeze, and the temperature of the fuel right now. So we need to heat the fuel all the time with the recirculation system that recirculates into the engine the fuel for heat. The air, the pressurizer on the left and right engine, the APU. We have also the doors are closed, the landing gear. So the doors are closed, the cabin can be pressurized, the landing gear, the left and the right. You can see the temperature of the brakes and the pressure of the tires, the flight controls here. So we have the flight controls. If we move all these things, you can see the left and the right wing and the tail, the vertical tail also, the position of all the flight controls are moving freely, there is no failure, and the horizontal tail trim and the rudder trim. So this is how you have the flight controls are working. You can see. So we have the FS display, the maintenance systems display, circuit breakers again. So we have systems, CDU info, checklist, communication systems again, and navigation display. So we have CDU over here. So this is all right now. We're going for the engine start demonstration. So we turn off both fuel flow, left and right, as you can see. So we turn off over here the fuel flow, over here left and right engine. You can see here we have the engine shut down right now, so there is no spinning. The N1 decreases, exhaust gas temperature also, M2. You will see in the overhead maybe a reset maybe now. So we go right here. I'm gonna see the forward of the wings of the Boeing 787. Have a nicer view of the aircraft, the Boeing 787. As you can see, both engines are right and left are off right now, so we're gonna restart the engines. Go here in the overhead panel and start the engine start. As you can see, engine start. You will see this is the engine start. The reset in the overhead panel, so we're gonna have pressurizer to the engines right now being flow so we're gonna have a higher pressure. As you can see, the N2 states above 20%. We can let the fuel flow right now to the engines. Above 20%, we can let the fuel flow to the engines like this. So you can see both right and left wing. So we start the engines right now. Both fuel flow over here, as you can see. I'm gonna let it to the run. So we're gonna have here the engines auto start right now here, as you can see. Again, left and right engine auto start position. You can see also the outside view. Both engines are running right now. So we have the auto start complete almost. Auto start and now running. Both engines running, so we can go proceed for takeoff right now. So now we're going for takeoff from the runway 14, so stay with me until the end part of the video. I'm gonna show you now the takeoff, climb, cruises, and approach the landing. We're gonna have the complete flight. Thomas Hatsios, German American pilot flying the Boeing 787. So we proceed now for takeoff. Advance the thrust levers here. Parking brakes over here, disconnect. So advance the thrust levers, also the flaps here for takeoff 15 degrees. So we have a little bit more advanced. And we have about 25 more minutes for this flight. So we take the clearance for the runway here. The runway is open for us for takeoff, so we only align with the runway here. So we advance the thrust levers to the takeoff ground position and disconnect the parking brakes and go. As you can see, use the rudder pedals for alignment over here. So we have 140, so we have V1, we rotate and we take off like this. So we have full takeoff power for the initial climb. And we have about 20 more minutes for this flight, as you can see. So we can see we are 1,900, 2,000 feet above the ground level. You can see above ground level, about 4,000 feet above the sea level. The airspeed 180 knots. And now you can see the trend line we're climbing, 5,500 feet per minute. The pitch altitude, you can see the terrain also around you and below you, the terrain level. You can see the ground. You will look closer like this if we move the map. You can see also the stall speed over here, so we need to level off to avoid stalling the aircraft. So this is the initial climb from the airport. Just take off the Boeing 787. So now we need to start the turn, as you can see. The flight plan also, as you can see, moving into the waypoints. The engines power also, and the position of the engines. So you can see here, as we have the initial climb, and we have 18 more minutes left here. We have the flight controls again. You can see I'm using the flight controls for flying the aircraft like this. So we can balance a little bit. So this is the aircraft after the first flight part. So we have a beautiful view over here, as you can see. The Zurich, Switzerland, and we have the Germany and the France in this way. The Italy behind us, so we're gonna make a nice flight. Boeing 787. So this is the Boeing 787. You can see. Hope you like it. The view. As we're flying. And now we're gonna have to cross this waypoint now. Over here. You can see it's moving a little bit. You don't need to move too much. For making some maneuvers over here. as we can see. Also, we're very close. You can see the airspeed. Now we have the stall speed. We're close, so we need to avoid stalling the aircraft. So we have to follow the waypoints and the flight path. And we have 16 more minutes left for this flight. Need to cross the waypoints here and keep climbing. We're 18,000 feet and we need to retract some flaps to increase the airspeed. So we have 16 more minutes left. Follow the waypoints like this, the flight plan. So we're gonna have the LNAV right now. Let's stay to the line and cross this waypoint here. And we have 15 more minutes left for this flight. So we have 14 more minutes left for this flight. So keep flying like this. We have beautiful views over here. The galaxy, as you can see, galactic view. The Switzerland over here. The Germany. We are gonna be overflying the Germany, the France in this way. So the galaxies, so keep flying, and we're going to Italy behind us. So we have the lakes, the beautiful lakes here, and the mountains. So keep climbing to the 3,000. And we have 13 more minutes left for this flight. As you can see, maybe 12 minutes. Need to increase the airspeed also here. So we have 12 more minutes left for this flight. We are gaining altitude like this. So we cross 35,000 here. We have the altitude. We keep climbing. 35,000 feet, and we are very close to start making the turn. We have a few more minutes, so we need to start turning in a while, as you can see, using this flight plan. We have stored in the flight management computer. You can see the legs over here. So we're gonna start now making the turn. As you can see, make the turn over here. Maybe wait a little bit more with 7,000 feet, and we have 10 more minutes left for this flight. So we need to start maybe making the turn like this. As you can see, we follow the flight plan, and we're flying here. We have also the chemtrails now, the frozen vapors, as you can see. The lake, and we have the Germany, the Bayern Munich, my homeland, from this side. Germany, the France behind us, and the lakes over here. So this is a beautiful view. The Boeing 787, and we need to continue the turn now. And we have like 9 more minutes left for the video part to end, for the record to end. So we need to level off here, have full takeoff power again. This is not quite helpful when you want to level off, and we have 8 more minutes for this flight. So we need to set also the altitude over here. And the airspeed, everything is set in the autopilot, so now we can cruise here, as you can see, cruise level, and increase the airspeed, flying level here, as we have it. And we have about 7 more minutes left for this flight. So now we cruise, retract the flaps, flying straight, as you can see. So now we're flying with my own hand flying like this. Need to level off with engines power down, So we keep flying straight, as you can see, level over here, 29,000 feet. Very beautiful view. We have the chemtrails and the galactic view, the frozen vapors. Let's see. So we have a few more minutes to go, like 6 more minutes for this flight. I believe we can make it. We need to connect also the autopilot now. We're gonna have the autopilot connected like this. Fly also manually with the autopilot now. We need to start the descent. And decrease a little bit the airspeed. So this is gonna give us 5 more minutes for this flight. So we keep descending over here. You can see the chemtrails behind us, the France this side. So we have idle now thrust, and the descent rate over here is gonna be higher than that. Flying like this, 7,800. And we have 4 more minutes left for this flight. We're overflying the airport right now. Need to concentrate how to make the approach over here. So extend landing gear. The pilot disconnect, and we take manual thrust again, and we keep descending, and we're gonna have this airspeed. Gonna make a more steep approach for the landing. As you can see, we can do that and extend some flaps. Start extending them. So this is gonna give us a very steep approach. Very steep approach, and we have 2 more minutes left here for the approach and landing part, so maybe we're gonna have enough time to record that. So you can see, keep flying manually, and we have like, oh, we have 2 more minutes left for this flight, so we're gonna make a very nice approach. 1 more minute. Increase the power again. You can see also we're gonna have a nicer view over here. Increase the airspeed, so we have a few more seconds. You can see the ILS localizer, all the information here in the displays as we are approaching full landing, the altitude that we are above the ground. The engine's down for the approach and landing. So we're gonna touch down now. We need to align with the runway. We have some side wing, so we use cross control, idle thrust, and we have the touchdown. Beautiful, very beautiful touchdown here. As you can see, parking brakes, idle thrust, and thrust reverses engaged. So we have idle and reverse, as you can see, and we're slowing down. You can see everything is pretty much normal over here. All the wheels, as you can see.